Okay, so this is for Algebra 2, 2, 3, 2, 4, slope and writing linear equations. Hopefully this will come back to you pretty quickly because you've seen it in Algebra 1 and probably at least a little bit in geometry. Now, slope is nothing more than measuring how steep something is. So if you're looking at this grade of a road, how steep a road is, you're talking about how much does it rise, how much does it go up over a specified distance. Slope is no different than that. For those of you guys that forgot, slope is exactly rise over run. And all you do is take y minus y over x minus x, and that is your slope. So slope of a line is the ratio of the change in y coordinates to the change in x coordinates. It kind of goes back to what I was saying on the previous slide. Y minus y, x minus x. Mathematically, it just means change in y over change in x. This means change for those of you guys that do not know. In math, it's not just a triangle, it also means change. All right, four things can happen when you have a slope. Okay, it can be positive, which means that it is going to go up and to the right. So this means positive. All right, so that means you have a positive over a positive or a negative over a negative. Both of those indicate a positive slope. Horizontal means that you have a slope of 0. That means you've got 0 over some number. Slope of 0 indicates that it never rises, but it just keeps running forever. All right, which is exactly what happens in the graph. It never rises, but just runs forever. All right, the other situation is that it could be negative. Negative means you've either got a negative number or over a positive or a positive number over a negative. Either one of those indicate that reading it left to right, it's going to go down. The last one's called undefined, and this is by far the one that kids get confused the most about. Undefined is a vertical line. And why is it called undefined? It's called undefined because when you do the slope, you end up with 0 in the denominator, and that's impossible. You cannot divide by a 0. So that's why undefined. That's why it's called undefined, because technically you're trying to divide by 0 and you can't do that. All right, parallel lines have got the exact same slope. Perpendicular lines have got slopes that are opposite reciprocals. And basically what that means is that one is negative, one is positive, and they're reciprocals of each other. Okay, so a quick example of that would be if I have one line that's got a slope of 4, the other line has a slope of negative 1/4, those two would be perpendicular. Or if I've got, 3 or negative 3 and positive 1/3, those two are going to be reciprocals of each other. So find the slope of the line that passes through negative 1, negative 1/4, and 1, negative 2. So that's just going to be y minus y, x minus x, so negative 2 minus 4 over 1 minus negative 1. So be very, very careful with signage. So that's going to be negative 6 over 2, so that's going to be a slope of negative 3. So graph the line with, graph this situation. So if you got a slope of 1/2 but it passes through 2, 1. So if I go over 2, down negative 1, I've got a slope of 1/2. That means I'm going to go up 1 over 2. There's my next point. That's all I need. Draw the line. So if I got a slope of negative 3, passes through negative 3, negative 4. So negative 3, 1, 2, 3, down 4, 1, 2, 3, 4. It's got a slope of negative 3. That means I'm going to go down 3 over 1. It's going to look like that. So slope, even though it's negative, you're going to go down and you're always going to go right. Just like over here on the left, you're going to go up, but you're always going to go right. It's always running right. It's just a matter if you're going up or down. So rate of change is kind of how slope is oftentimes represented. So rate of change is measure how much quantity changes relative to time most of the time. So if you take a look, how much does the temperature change over the course of time? What is the average rate of change of temperature from 8 a.m. to 10 p.m.? So the way that works is this. You're going to take 47 minus 36 over 10 minus 8. Okay, these become your x values. These become your y values. So 47 minus 36 is still 11, I hope. So the average rate of change is going to be 5.5. So in the context of the problem, that means it's 5.5 degrees or 5.5 degrees per hour. So what's the average rate of change from noon to 4? So noon to 4, you're taking this one and this one. So I'm going to take 60 minus 55. So I'm calling this my y2 and this my y1, obviously, and this is x2 and x1. So I'm going to go 60 minus 55, and then I'm going to go 4 minus 12, but it's really 16 minus 12 if you go military time. But either way, but in this context, that's kind of the way I want it because I want it to be, it's going to be a positive change. So you have 5 over 4, so you're going to have 1 1/4 degree over that time. Last one, during what 2-hour period was the average rate of change the least? So just looking from every 2 hours, where was the rate of change the least? So where was the least amount of change? I would say this one right here. So I would say from 2 to 4 p.m. So Kevin's savings account balance changed from 1140 in January to 1450 in April. Find the average rate of change per month. Okay, so dollar amount, month. That's kind of what we're using here. So I would say in month 1, because that's January, he has he's got $1,140. And in April, that's the 4th month, he's got $1,450. That would be the 2 points I would use to kind of figure out his average rate of change. So I'm going to take 1450 minus 1140 over 4 minus 1. So that's going to be, let's see, $310 in the top divided by 3. So it's going to be about $133.33 per month. So that's going to be your average rate of change over that course. All right, slope-intercept form. Slope-intercept form is probably the most common form that you guys have seen. So that's just y equals mx plus b. You guys have seen that before. M is your slope. B is your y-intercept where it crosses the y-axis. You guys have seen that before. That's nothing new. The other type of equation that we will write will be point slope form, which might not be as familiar to you, but this is it right here. And basically, x1 and y1 represent a point. M still represents your slope. So if you're just given 2 points, so you're going to first find the slope like we did before, and then throw it into point slope form. And then once you have it in point slope form here, rearrange it to make it look like slope intercept. So write an equation in slope intercept form for the line that has a slope of -3,2 and passes through for -1 or -4,1. So start with point slope form. So this is x, this is y, so I want y minus 1. Slope is -3/2, parentheses, x minus a -4, so that'll be x plus 4. So now make this look like this. So you gotta do a little algebra here. So you have y minus 1. That's gonna be -3/2 x plus -6. Okay, so that's just a fancy way of saying -6. So now add 1 to both sides. So y is going to equal -3/2 x minus 5. There's slope-intercept form. Slope is still the same. It's just where does it cross the y-axis. So write an equation, number 6, write an equation slope-intercept form for a line that passes through -1, 4, and 4, -5. All right, so here I got to figure out my slope first from those two. So I'm going to take 5 minus 4 Then I'm going to take negative 4 minus a negative 1. Again, careful with signage. You're going to be left with 1 over negative 3. So my slope is negative 1/3. Now I need to take my slope and one of my points and put it in point slope form. And then convert that to slope intercept form. So just kind of like I did over here. So it's going to be y minus 4 equals negative 1/3 x minus 1/3, add 4. So y is going to be equal to negative 1/3 x plus 3 2/3. There is the equation. So this last one, which I'm going to move back over here. Write an equation in slope-intercept form for a line that is parallel to 3x plus 1 and passes through 2, 3. So this is a great problem because I want to take this point, I want to take the slope off of this. So I just want to take 3, and I want to figure out my own slope-intercept line. So there's my slope right here in 3. 2/3 is my point. So there's where I start with point slope form. So that's my setup there. I take the slope off the line that's parallel because it's got the same slope, and I use my other point, and then I just kind of work it out like I did the other two. So there is my line. Okay, last one. So a salesperson, Eric, is paid a daily salary plus commission. When his sales are $1,000, he makes $100. When his sales are $1,400, he makes $120. Write a linear equation to model this situation. Okay, so two big pieces of data here. $1,000, he makes 100. $1,400, he makes 120. So write the linear equation that's going to model this situation. So here's kind of my data. So I've got 2 points, 1,000, 100, and 1,400, 120. So now that's my 2 points. So from there, I'm going to figure out my slope. So 1/20th is my slope. So now put that into point slope form. So let's go y minus 100. And again, you could use either point, just 100 and 1,000 sound like really easy numbers to handle to me. That's 1,000, not 100. So let's get it into slope intercept form. So that's going to be y minus 100, 1/20th x minus 1,000 divided by 20. So that's going to be 550. So now add $100 to both sides. So my equation is 1 over 20x plus 50. So there's my linear equation. All right, that's all I got. Make sure you show me your notes when they're done and get going on your assignment.